A black hole doesn't need to devour a star to prove it exists. Some betray themselves only by bending starlight. One lights up on schedule, precise enough to set a clock by, a rhythm traced back over a century. And one proves so hard to see, it took a telescope network spanning an entire planet just to catch its shadow. The X-ray ghost in Cygnus. In November 1970, astronomers pointed the new Uhuru satellite at a source of X-rays in the constellation Cygnus, and the readings did not behave like any ordinary star. A blue supergiant sat there, but something unseen was pulling gas off its surface into a spinning disk, heating it to millions of degrees, hot enough to glow in X-rays instead of visible light. That kind of heat only comes from gas falling towards something with no surface to land on. Gravity so total that the material screams on the way down. Picture standing near that disk. You would not see a monster, only a whirlpool of light bright enough to outshine 100,000 suns, spiraling into a point smaller than a city block. But the real argument started over what to call it. In 1974, physicist Stephen Hawking bet fellow physicist Kip Thorne that Cygnus X1 was not a black hole at all, a wager built as insurance against his own theory. Hawking conceded in 1991's the evidence became undeniable. He broke into Thorne's office with a colleague to pay up and signed his own defeat with a thumbprint on the original bet, a strange footnote to the first stellar black hole science ever confirmed. The Wanderer with no star. For years, one gravitational signal kept bending starlight from a patch of sky where no star, no galaxy, nothing bright enough to explain it could be found. Astronomers had picked up gravitational microlensing. A massive object passing in front of a distant star acts like a lens, briefly brightening and warping that star's light, even though the object itself stays invisible. The shape and length of that warp is the only fingerprint a lone black hole leaves behind. If you cross that patch of sky yourself, you would feel nothing, see nothing, and still be bent by a gravitational field strong enough to distort starlight from thousands of light years away. In 2022, the Hubble Space Telescope tracked the object's motion precisely enough to confirm it was real, roaming free through the galaxy with no companion star tying it down. But nailing down exactly how heavy it was turned into its own fight. One team calculated around 7 times the mass of the Sun. A rival team, using the same data, argued for a smaller number. The irony is that the hardest part was never finding the invisible object. It was agreeing on how much of it there was. The black hole's older than stars. Long before the first star ever ignited, the early universe may already have been making black holes. In 1966, physicist Yakov Zeldovich proposed that some pockets of the newborn universe were dense enough for gravity to crush matter directly into a black hole, no dying star required. Physicist Stephen Hawking expanded the idea in 1971, arguing that the raw unevenness left over from the Big Bang itself could have done the collapsing. That would make some black holes older than every star in the sky combined. If you existed inside one of those dense pockets in the instant after the Big Bang, you would feel space itself curving past the point of no return, squeezed into a space smaller than the head of a pin, before a single atom had formed. But decades of searching turned up not one confirmed example. Some scientists believe primordial black holes never existed at all. Others believe they are still out there, small and ancient, making up part of the invisible dark matter that outweighs every visible star, galaxy, and planet combined. Today's gravitational wave detectors are built partly to catch two of them colliding and finally settle it. The merger that shouldn't exist. On May 21, 2019, gravitational wave detectors on opposite sides of the planet caught a ripple that did not fit the textbook. Two black holes, roughly 85 and 66 times the mass of the Sun, spiraled together and merged into one of about 142 solar masses in a fraction of a second, releasing more energy than every star in the visible universe combined. Picture two objects, each heavier than 80 suns, crossing the last few hundred miles between them at a third the speed of light, then colliding into a single point. Physics says a dying star cannot collapse directly into a black hole in that specific weight range, since the pressure inside a star that massive should blow it apart in a supernova, leaving nothing behind at all. So the real problem was not that these black holes existed. It was that one of them should never have formed from a star in the first place. The leading explanation is that it was already a black hole, built from an earlier collision, then pulled into a second merger that made it heavier still. A black hole assembled from other black holes, stacked like nesting dolls of collapsed stars. The shadow wider than our solar system. 55 million light-years away, in the galaxy M87, astronomers pointed 8 telescopes spanning from Hawaii to the South Pole at a target almost too small to see, and on April 10, 2019, they released the first image ever taken of a black hole's shadow. Photographing it required linking observatories across the entire planet into one virtual telescope the size of Earth itself, a technique project director Shepard Dolman and his team spent over a decade building. What came back was a glowing ring of superheated gas bent around darkness, the exact shape general relativity had predicted more than a century earlier. If you could walk around the edge of that shadow, the trip would take you past a boundary roughly 6.5 billion times heavier than the sun, wrapped around a gap in space wide enough to swallow our entire solar system many times over, planets, orbits, and all. What nobody expected was the size. Astronomers had aimed the most ambitious telescope ever built at one galaxy, and the thing it photographed turned out too large for the comparison anyone had prepared. A shadow that big, still small enough in the sky to need a planet-sized camera just to catch it at all. The black hole in your basement. If you remember the news in the fall of 2008, you probably remember the warning. Scientists in Switzerland were about to switch on a machine that could create a black hole and swallow the planet. The Large Hadron Collider was designed to smash particles together at energies never reached before. And a handful of physics theories involving hidden extra dimensions predicted that a fraction of those collisions could briefly produce microscopic black holes. Stephen Hawking's own physics said any such black hole would evaporate almost the instant it formed, radiating itself out of existence before it could cross a distance thinner than a human hair. Stand right next to a collision like that, and you would not even register it happened. Over before your nerves could send the signal. Lawsuits were filed to stop the machine from switching on. It switched on anyway in September 2008. Safety was never actually the question physicists cared about most. It was whether hidden extra dimensions were real at all. After more than a decade of recorded collisions, the count of confirmed microscopic black holes sits at 0. The headline monster never showed up. The machine just kept finding other things instead. The punch that lights a galaxy. Every 12 years, a distant point of light called OJ287 flares bright enough to briefly outshine its entire host galaxy. And for over a century, nobody knew why. Photographic plates going back to 1891 recorded the pattern, but it took until 1988 for astronomer Imo Sillanpää to spot the 12-year rhythm buried in a century of brightness records. The strongest model says 2 black holes share that galactic core. A primary weighing around 18 billion suns, one of the heaviest known, is orbited by a smaller companion of about 150 million solar masses. On its tilted, stretched-out orbit, the smaller black hole punches straight through the larger one's disk of superheated gas twice on every lap, flash heating it into a burst of light that briefly overpowers billions of stars. Watch one full orbit and you would wait 12 years between shows. Then watch the sky flare twice within a single year as the smaller black hole crashed in and back out. Physicist Mari Valtonen used the orbit's relativistic wobble to calculate the week of a future flare years ahead of time, and in 2019, the flare arrived on schedule. That kind of precision has made OJ287 one of the most demanding tests general relativity has ever passed, still ticking away toward a merger roughly 10,000 years off. The monster at the center of everything. In 1974, radio astronomers Bruce Ballack and Robert Brown pointed their instruments at the exact center of the Milky Way and found a source of radio waves unlike anything nearby. For decades afterward, astronomers tracked individual stars whipping around that same point at incredible speeds, one completing a full orbit in about 16 years, only explainable if something with millions of times the sun's mass was packed into a region no bigger than our solar system. In May 2022, the Event Horizon Telescope finally imaged it directly. Sagittarius A star, about 4,300,000 times heavier than the sun, sitting 27,000 light-years from Earth, its shadow wide enough to line up close to 20 suns side by side across it. Cross to the true center of our galaxy in your mind, and every star you have ever seen in the night sky would be orbiting that one dark point. What made this image harder had nothing to do with distance. Gas around Sagittarius A star shifts shape within minutes instead of days, so imaging it was less like photographing a mountain and more like photographing a puppy that will not sit still. The hole too big to agree on. A faint blue point of light sat in a 1957 star catalog from the Tonantzintla Observatory in Mexico, filed away with no idea what it actually was. Decades later, spectroscopic analysis showed it was not a star at all. It was a quasar, the blazing core of a distant galaxy powered by matter spiraling into a black hole so large that even conservative estimates put its mass at tens of billions of times the mass of the Sun, among the heaviest ever measured. The light reaching Earth today left that quasar over 10 billion years ago, journeying across most of the observable universe just to get here. Imagine falling toward TON 618. The boundary alone would stretch many times wider than the orbit of Pluto around our Sun, a gap in space large enough to file entire solar systems inside without touching the edges. Different measurement methods still land on different numbers, ranging from tens of billions to some of the highest figures ever proposed for a single object. But every method points to the same rank among the very largest black holes ever found. Something powerful enough to outshine its own galaxy spent its first sighting filed away as an unremarkable point of blue light in a routine survey. Subscribe for more of the universe's strangest objects explained.